GM, hey everybody. Let everybody slowly join us. We are here for another workshop in our workshop series, another library workshop. We're joined by Vivian from PSE, and she'll be walking us through ZK-Kit. So she'll introduce ZK-Kit, she'll show us how to integrate it into our projects, and then we'll go into some code examples to help really get started super fast. So I will hand it over to Vivian to walk us through ZK-Kit.
Hello, my name is Vivian Plasencia, and I'm a software engineer in the Privacy and Scaling Explorations team at the Ethereum Foundation. And today, I'm going to talk about ZK-Kit in practice. Let's start. This is the structure of the presentation. I'm going to start with what is ZK-Kit. Then I'm going to mention the ZK-Kit repositories. Then I will talk about the core principles, ZK-Kit Noir. I will also talk about the flow of zero-knowledge applications. I will talk about how to use ZK-Kit. I will show some code examples and how you can get involved with ZK-Kit too. Let's start with what is ZK-Kit. ZK-Kit is a set of libraries such as algorithms, utility functions, and data structures that can be reused in different projects and zero-knowledge protocols, making it easier for developers to access user-friendly, tested, and well-documented code. There are 5 repositories so far. There is one for TypeScript, JavaScript, another for Noir, Solidity, Circom, and Rust. You can find all the repositories in every repository has all the repos, so you can find all of them in ZK-Kit, and then the others have links to the other repositories too, so it's easy to go from one repository to the other. These are the core principles of ZK-Kit. The first one is modular and independent packages. The packages are independent, so you can use a package. You don't need to use others, just with one is fine. They are independent. Dry principle. This is don't repeat yourself. If you are writing a code many times, you are writing the same code, it's better to abstract it and have a library for that. So that's the idea of ZK-Kit too. Consistent cross-language APIs. This means that if you have ZK-Kit has the same data structure implemented in many different programming languages, so they are consistent in the name of the functions and the parameters. So if you use one data structure, you will probably find the same function in all of them. We always try to be consistent with the different data structures in the same language so that it's easy for people to switch data structures too. Interoperable implementations across languages. This means that since the same data structure can be implemented in many programming languages, every data structure is optimized for its implementation in that ecosystem. For example, if there is one data structure for Merkle trees in TypeScript, it's optimized for the TypeScript ecosystem. And if this same data structure is implemented in Solidity, it's optimized for Solidity, for smart contracts, and the same for Noir and for all of the others. So that's the idea of this principle. Also, well-tested code base. Tests are very important. So we always try to make sure that all lines are covered and all branches. Security through audits. We recently finished an audit for Semaphore version 4, and it covers some ZK-Kit packages, and we want to have more audits so that it's more secure to use these libraries. Performance benchmarks. Comparing different data structures is always important, so that it's easy for you to decide which one you need. And contributions are very welcome. So that's another important thing. Let's talk about ZK-Kit Noir. CKKit Noir contains the following packages so far. One for Merkle trees. There is an implementation of a binary Merkle tree and also sparse Merkle tree. As I mentioned before, they are compatible with the TypeScript implementation, for example. So the idea is try to make them compatible, optimized for each ecosystem, but still compatible. There's another package called ECDH and another one called binary Merkle root, which I will be talking about during this presentation. This has been the most popular so far since you have been asking for it lately, so I will cover more about it. And I will also explain more about the code and everything and how to use it. You can use CKK-Noir like similar to the other libraries in Noir, in the Noir ecosystem. For example, the binary maker fruit, you just add the dependency, like you add the GitHub URL, the tag, and also the directory, and that's it. You add this and then you can just import it. You import the library and the function, and then you can use it. I will explain more this library and also show an example on how you can use it. But here you can see that you send the hash function, you send the leaf, and also the depths and the indices and the siblings, like membership proof, and then you can calculate the root, because the idea of this library is to calculate the root of a binary Merkle tree. This is the flow of a general zero-knowledge application. The user will interact with the front end, the user interface, and then the user interface will interact with the backend, a web to backend, or smart contracts. Something important here is that to generate the proof, the proof generation is always in the front end because it will probably use private data. So it should be in the browser or the phone, and the proof should be verified in the backend in smart contracts or a web to backend so that we can know that it's correct or not. That's important to know that the proof generation is always off-chain in the browser or the user interface, and the proof verification is always in the backend. This is a diagram to show how you can use StickerKit. In the NOR ecosystem, you will have your NOR circuits, then you will have your logic for your circuits. Using the binary maker root as an example, you imagine that you want to calculate the maker root, then you will have your logic, and then you will use this library and have your circuits. And then for the front end, since the libraries are compatible across different ecosystem and programming languages, you can use any binary maker tree from CKKit. In this case, I'm gonna talk about the lean incremental Merkle tree, which is an optimized version of the incremental Merkle tree. In CKKit, there is also a data structure called incremental Merkle tree, but we've recently created this lean incremental Merkle tree for Semaphore version 4, which is an optimized version of the incremental Merkle tree. So I will suggest you to use this one if you need an incremental Merkle tree. And in this case, in the front end, to generate the proof, you will use the JavaScript implementation of this data structure. And then to verify it, if you have a web to backend with TypeScript and JavaScript, you can use the same implementation in JavaScript. And if you use Solidity to verify the proof and for the logic of your program, you will use the Solidity implementation. These are the same data structure, but each implementation is optimized for each environment. So the implementations are not the same, but they generate the same results because one implementation is optimized for JavaScript, and then the Solidity implementation is optimized for smart contracts like gas costs and things like that. So let's show some code examples. Here is the CKK-Noir repository. You can, if you go to the README file, you will find the other repositories. And the documentation for each package is always in the README file. So you can find the code examples there. And the README file, the main README file, will always have the repositories, the packages, and the ways to contribute, how to install it, how to use it, and test it. So in this repository, I'm gonna talk about the binary maker root, for example. This can be imported like this, and this can be added to the dependency. Just copying this. And for example, you have been asking about this circuit lately, and I'm gonna talk a bit about it. And this is a circuit to calculate the root of a binary Merkle tree. It's compatible with the incremental Merkle tree from CKKit, also with the Lean incremental Merkle tree, with any binary Merkle tree. And the circuit is designed to, as a dynamic, is designed to calculate the Merkle root for smaller tree depths. That's why there is a max depth parameter here. The idea of this max depth is that it's mainly for the artifacts. If you generate this circuit, if you use this circuit and your circuit uses max depth 32, for example, then you can use, with the same artifacts, you can use tree depths up to 32. And the idea is to allow this, because if we don't do that, then we will need to create artifacts for all of the tree depths. And this is better. It's better to use the artifacts of every tree depths, because this way you can, the circuit artifacts are smaller, but in case your application needs just artifacts for one tree depth, it's better to use the biggest one so that you can support all of the tree depths less than or equal to that one, that max depth you decided. And this circuit will go to until max depth, and then we'll be calculating until the depth the root using the membership proof. Like if it's the index is 0, the node will be in the left, and then if it's 1, it will be in the right, and they will use the hasher, like the hash function you send, to hash it, and then you will get the root. So that's the idea of this circuit. Then I want to show the TypeScript equivalent. So that one is to calculate the Merkle roots, but you can use this library in TypeScript in the front end, or in the back end is in JavaScript, to, at the same time with these other binary Merkle roots circuits. So that's the idea, to use different packages in different ecosystems, but they are all compatible. And here is the implementation. This is the way you can install it and use it. And this here you can find the functions. I'm gonna talk about the example of circuits using these libraries. I'm gonna talk about the semaphore version 4 implementation in Noir. This is an ongoing implementation and research implementation by the HashCloud team. They have been doing a great work with that. And here you can see how this library can be used. For example, in here, the max depth will be up to 10. For example, we will need to have 32, but this is an example. And this is related to semaphore, like identity. But here you can see how this circuit can be used, how this library can be used. This is the hash function, it's Poseidon, for 2 elements. Then this is the leaf, and this is the depth, and then the indices and the siblings. So the way to use it is the same. You just try to use it according to your application and what you need. Because, for example, for RLN, which is another implementation, a new implementation of the RLN protocol using the latest features of Semaphore version 4, like the identity schema with EDDSA and the lean incremental marker tree. This protocol also uses this library because it needs to calculate the Merkle roots, and then it's the same. Like it's Poseidon, the commitment is different, the leaf is different, but it's still the leaf of the tree, and then the depths and the indices and siblings. So it's the same. And then if you check, here is the dependency. So how you can get involved? So if you have an idea for a new package or a new algorithm, something that can be helpful for the programmable cryptography space, for applied cryptography, for zero knowledge applications, that would be great if you create an issue or ask to add it, because the idea of CKK Noir is to provide this kind of functions and libraries for people creating zero knowledge applications and apply cryptography. So that's the idea of CKKit in general. So you can work on open issues. You can also suggest new libraries. You can share ideas for new features and also report any bugs you find in the code. And for that, you can go to GitHub, or you can also go to the PSC Discord. Here is the QR code, and there is a channel for CKKit. You can also ask questions there, join discussions, or create discussions. And yeah, you can contact me on Telegram, GitHub, Discord, but feel free to tag me on the Noir Discord or PSC. Yeah, I will answer there too. So yeah, thank you very much. Feel free to ask any questions, or if you want me to answer something specifically or show some code.
We have a couple questions in the Q&A from Manza. You want me to read them to you? I know while you're sharing, it's a
Yeah,
little hard to do.
I'm going there.
Oh, okay.
Yeah, but feel free to read them.
Sure. Yeah. So the first one is, what's the current implementation status of Semaphore, and are there any plans to implement Macy? We're planning to use both in our project.
That's cool. So Semaphore, the circuit is ready, and there are some benchmarks. So we will have more benchmarks, and there is also an ongoing research development for proof recursion. And yeah, so I can share the link to their work, the repo. I will share the link to the repo in the chat.
Okay. Okay, awesome. I think the follow-up question to that was just around the initial implementation for Semaphore, and if you could share that. So if you can share that in the chat, I think that would be good for Monza. And
Yeah,
then
I'm gonna share that.
Octavio asked, have you documented the format / requirements for an algorithm to be a part of the kit? I like the format and the idea. It might be good to have parallel sets of functions in this fashion, but perhaps some of them are not general enough to be worse in the main repo. So he's just asking about like if there's a format for, if I guess he wants to maybe submit some stuff for the algorithm part.
Yeah, in the issues you can find the information when you want to create a new issue, suggest an idea. So feel free to create the issue as you prefer, create the idea, and then we can discuss it there. And then if you are interested, you can also create the PR to add this new package and algorithm.
Cool, awesome. Any other questions from anyone? I see Savio is in the chat. Oh, Octavio asks, are there any strong cryptographical warrants that all implementations do the same?
Like, I don't understand like the question. A different way to say the same thing.
Octavio, you want to add a little bit more context to what you're asking? So he's asked, you're able to see the Q&A now?
Yeah. Is there a set of tests ensuring all of them deliver the same results for the same input environments? Yeah. There are tests for every package and for everything. So you can check that they are all compatible. And they are actually in Semaphore and in Macy and some protocols. They are using, we are all using these packages, and yeah. So yes, there are tests, and also there are real world protocols using them.
Awesome. I have some questions for you. Maybe you could share if there's any use cases or example applications that you could think of that would benefit from using ZK-Kit. So in the NoirHack program, people are trying to build cool applications that really actually are useful and on the application layer. Really for the first time, part of the whole message of NoirHack is that now is the time to build real apps. Are there any real apps that you envision people building that they could use ZK-Kit to make way easier to build?
Yeah. Yes. So the idea of someone mentioned Macy, it would be really cool. I don't know of anyone or anything working on that. So it would be super cool. And for Semaphore, there is already an ongoing research development process. But for example, for RLN, which is similar, I created the circuit, and the circuit is the one I showed before, but it would be nice if someone take this circuit and improve it or maybe optimize it. If there is a way to optimize it, they optimize it and make it production ready so that RLN can be used in real life, but created with Noir. That's an interesting protocol too. So yeah, Macy, RLN, these kind of things are really interesting because these are protocols that are used in real life. RLN is used by Waku, for example. They have their own implementation, but it's useful. And Macy is used by many projects too. So yeah, for Semaphore, there isn't already, but for these other two protocols, it would be super nice to have this. And also if someone is using the same circuit, or if as someone creates a circuit that can be reused by other people, it would be nice if they just add it to ZK-Kit so that many people can use it. And also at some point the circuit will be audited. And yeah, so if someone wants to add a new circuit, that would be cool too, or create issues, these kind of things. Yeah.
Awesome. Maybe you could also share a bit more on, for those people who are joining either via the recording or now, who are maybe a bit more new or beginners or intermediate to Noir. You could talk a little bit about how using ZK-Kit compares to manually implementing some of these primitives and how much easier it could make. Maybe you could talk about like some of the trade-offs and why it's like so useful to be able to use this instead of just rewriting all of these primitives.
Yeah. Yeah, I think the circuit I mentioned before, the binary maker root, is a great example because if you create this circuit from scratch, you will probably have the functionality, but it won't be optimized. So the HashCloud team worked on that, and then it was optimized in a way that if you just integrate it, you just need to know that it's optimized. It was optimized for some people, and you can optimize it too, but it was already optimized, which is great, so that you don't need to create the same thing. And and you can just know that it was well tested, it was optimized, and that's cool. And so I think that's the main advantage of using. It's like the advantage of using a package that was tested by many people, other projects that is being used in some projects. So that's the idea, that yeah, they can use it directly to get the functionality and the security and and everything. Yeah.
And how do you guys envision ZK-Kit kind of evolving in the longer term? What are some? So you mentioned a little bit about like Macy and other examples, but like maybe in the longer term, what excites you for ZK-Kit? Like, what do you think it will be able to do and solve?
Yeah. I would like to see many people contributing in a way that we all add code there. The zero knowledge ecosystem, the applied cryptography ecosystem, add libraries and circuits there so that everyone can use it. And we all know that it is correct and it was audited, it was tested by many people and projects. So I would like to see that many people using and adding circuits and libraries there so that we know that that's correct. I think that's the idea, to have a package that many people can use, and these people that are using it will optimize the package, and then the package will be better, and then other people will use it, and then we optimize it, and we will be better. And in the long term, it's going to be audited, well tested, and working well. So I would like to see this project as a community project, like many people involved and helping, not just a few projects, but many people. Yeah. Right now, there are quite a few projects using it and contributing, but I would like to see even more people and projects and teams doing that. Yeah, in all the programming languages.
So you mentioned also auditing. Could you share more about the timeline on that? And then you also mentioned that there are some teams that are building with it. Maybe you could share like what cool stuff people are already using with ZK-Kit, or people are already using ZK-Kit for.
Mm. Yeah. For there was an audit, a recent audit for Semaphore version 4 for the latest version, and there were some packages from CKKit. So some packages like the linear incremental tree were audited, and the idea is to plan an audit for other packages too. And some other projects using CKKit, I would say Macy. Macy is also using CKKit. And I have seen other projects, also Supas, the Supas team. And usually people use it for Merkle trees, for the incremental Merkle tree, the linear incremental Merkle tree, since it's more recent, the linear incremental Merkle tree. People started to use that one too. So I would say mainly for membership proof and Merkle trees. Yeah, people have been using that. Yeah.
What for you? So, um, maybe you could share about any pitfalls, challenges, resources for you, like in learning Noir, if you have been working on more Noir projects, working on this Noir part of ZK-Kit. Like you could maybe share some resources that were helpful for you, and then also like any things that you found like challenging, interesting in like no learning and getting more familiar with Noir.
Mhm. Yeah, I think the documentation is really good. And the code that people create, this is useful. Also, that's one of the interesting part of CKKit, that people can use the code to learn about this language, not just the data structure, but also the language. So some resources, I follow the documentation. It's great. The NOR documentation is great. Yeah. So it's been very helpful. And code I found from from Discord, the NOR Discord, and yeah, the on GitHub too.
Were there any like things that were like gotchas where you felt like something should have been a certain way and then you got like stumped and then you realized like, oh, actually this is in this way, like something that maybe
Yeah,
developers could
something.
be more aware of?
It's something we have been discussing in the Noir. This square is the dummy square that for example, the semaphore circuit has a dummy square because the input won't be constrained if you don't create this dummy square. And it looks like in R, that's not necessary, which is cool because all the input are constrained. So that's interesting to me because, yeah, it makes sense. And it's really nice that we don't need to create this dummy constraint. And I really like that. And I also like that this circuit, the binary maker fruit, has the hasher as a parameter, so you can use the hash function you want, because by default in Circom, you will need to use a specific hash function. And here is more general. You can use the one you prefer, which is great because it's more abstract. I really like that too. Yeah, I really like that about NOR. Mhm.
What other nice stuff can you say about Noir?
Mm. Yeah, so mm,
No
I
pressure,
think
no
it's a good
pressure.
developer experience. No, but it's a good developer experience to get started. The community. I like the community and people around it. Yeah, very helpful. You ask questions and there's always someone answering, which is great. And that's super important. I really like that.
With ZK-Kit, are there any gotchas or things for people to keep in mind as they integrate it? So either as they maybe make contributions or if they start using any of the primitives, is there anything that you think is especially important for people to keep in mind? Probably a lot of it you've maybe already covered, but anything that um, mhm.
Just know that if you're using a data structure, it's probably implemented in another language. Like if you're using it in TypeScript, it's probably implemented in another language. And if it's not implemented, you can create an issue in a PR to implement it. And that's something important to keep in mind because they will be compatible. So if you use one in one ecosystem, it's better if you use the same one from ZKKit, but in the other ecosystem you need that. So that's important to keep in mind. And yeah, and if people need something or have questions, they can always ask on GitHub or in the BSC CKKit channel on Discord. So yeah, and we will always answer.
Awesome. I think so far there's not been any integrations with like front end tools like with Noir.js. I think that would be something I would want to see someone build potentially. Has there been anything like that so far? I know it's quite new, like the Noir part.
Mm. Yeah, the semaphore node implementation, they are integrating the JavaScript part. So they already did that and they already created benchmarks. So so yeah, this is the first approach to test this. So no, there are not others packages. No, for Circom, there is a package, for example, to convert for example, the gross 16 proof compatible with both the contracts and the backend with TypeScript. And something interesting will be to explore if this is necessary for NOR, for the JavaScript part. I haven't taken time for that, but that's something I have in mind because there is a library to work with that with Circom because of the way everything is done in Node.js. So if this is necessary for Noir, it would be nice to create a library or a function for that so that people can create protocols in a way that when they generate the proof, the same proof can be used on-chain and off-chain. Because with Snark.js, if you generate the proof, this can be used directly with Snark.js in the backend, but you need to convert it to use it in smart contracts. So the way we are doing it in Semaphore and we did with CKKit in the library was to just convert it to be compatible with smart contracts so that we save gas. And then we convert it in JavaScript when we want to verify it. So if in order this needs to be done, it would be nice to add that function to CKKit JavaScript repo so that this functionality can be there too. But maybe that's not necessary because I haven't checked, but maybe the same proof can be used both places directly. But yeah, I haven't checked. But if this is necessary, it would be nice to add these functions.
Yeah, if whoever's listening and wants to contribute, this would be a good thing to potentially build, or at least to check to see if you can use it in the front end. I think for any project that's going to use this, they'll probably likely need to support that. So if someone is interested in building that, we would love to see that. In general, maybe you could share a bit about contributors. So you guys are looking for people to help contribute, to add resources, to share primitives. And I think maybe there's going to be some potential incentives as well for PSE from PSE for this. So maybe you could share like how you're thinking about contributors, as I'm sure that there are people listening either live now or in the recording that could be interested.
Yeah, we are still organizing this part now, but the general idea is that people can just go there and propose ideas. There is not like an official way to do it, like you need to do this step and then this other. It's just you go there and you create an issue and you share your idea. Feel free to always share your idea. And yeah, it's not that it's not 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 difficult. Just go, share your idea, and that's it. We will discuss it there. And then yeah, if you need a primitive that can be interesting for CKKit, just drop the idea there too, so that we can work on that and or someone can work on that. It would be better if someone from the hackathon work on that. So yeah.
We have one question right now from NoirHack. She's asking where they share the ideas. I think you mean just like GitHub
Yes.
issues, like in the repo,
Yeah,
or is there a
GitHub
specific
issues
place?
or yeah, in the presentation there is the PSC Discord. You can go to that place too. If but both are fine, wherever you prefer. GitHub issues with any repo. If it's Noir, you go to the CKKit Noir repo, go to the issues and create an issue. And if you want to just discuss in a chat, you can go to PSC CKKit channel. And yeah, that's fine too.
Cool, awesome. Yeah, I will share some of these resources afterwards in our Notion. We have a Notion, which is our start page. So I'll share like the PSC Discord, the slides that Vivian went over, the actual links to ZK-Kit for JavaScript, TypeScript, Noir, even the Circumon as well. But cool, yeah. Does anyone else have any more questions for me or for Vivian before we maybe close a few minutes early? Just thank yous. Cool.
Yeah, thank you.
Awesome. Well, unless Vivian, there's anything you want to add, we can maybe close here. Thank you for an excellent presentation.
Thank you. Thank you very much for inviting me. And yeah, super happy to be here. Thank you.
Awesome. Yeah, super excited to see what people build and hopefully what they contribute to ZK-Kit.
Yeah.
Cool. All right. Thanks, everyone.
Thank you.
Have a good one. See
Thank
you in the
you.
next workshop.
Bye.
Bye, guys.